Okay, good morning, everyone, and welcome again to day 3 of the virtual workshop series on water resources management and irrigation in Kansas. So this workshop is organized by the K-State Research and Extension Natural Resources Program Focus Team and the Kansas Center for Agricultural Resources and the Environment. So this series are also entered as a professional development event for county extension agents at K-State Research and Extension. Jonathan, please, next slide. So please sign up for it if you feel like it's a useful development event for you. Previous slide, please. So we started this series last week, and we had 2 sessions on sustainable water resources and irrigation technology and management. So today we are continuing this. This series can be accessed through the same Zoom ID with the same passcode. And also it's live streamed on YouTube. Next slide. The format, please mute your microphones. And if you have any questions, record them on the chat sessions and we will voice them at the end of the presentations. So we will also have panelists at the end joining the presenters. Although our end time is posted as 9:30 a.m. If the discussion continues, we will not end the session, so please stand by. And with this, I will turn it over to Jonathan Aguilar, who is the moderator of this session.
Yes, good morning, everyone. It seems like this is a very nice topic to talk about, particularly as we have experienced a good blow of wind yesterday. So let's talk about climate and water resources. And we are happy to talk to have us with us today, 2 people that are really working on this matter. I would like to introduce the 2 speakers for today, Mary Knapp, which is our climatologist, as well as Chip Redmond, our meteorologist with K-State, assistant meteorologist. And they will be joined later on by David Hallower and Cody Miller, both an agent that are going to probably join the discussion as well. So without any further ado, I would like to invite our speakers to start the process, and I will be monitoring the questions in the chat as well as many others. And so if you have any questions, feel free to just type it in the chat, and we will try to address them at the end of both presentations. So
okay, so we're going to talk weather and climate. I get to start first and talk about the climate. So Jonathan, if you move to the next slide. First thing we need to review is some of the terminology that's being used. Climate is the weather trend over long periods of time. We're talking decades and centuries, where weather is the day-to-day state of the atmosphere. It's short-term and immediate impact. And we're feeling that weather as the cold front barrels across Kansas, and temperatures are dropping fairly rapidly with that. Next slide. Another piece of terminology is normals. Normals is a 30-year average that's updated every 10 years. It serves as a baseline to compare how the current weather compares to long-term patterns. And it also is used as a baseline to measure change. Are we getting warmer? Are we getting wetter? Current US normals use the 1981 through 2010 timeframe. The updated normals, because like I said, it's updated every 10 years. The next period will cover 1991 to 2020. and it's expected to be released in May of this year. It probably won't be widely utilized until the start of 2022. It takes a while for people to integrate it into their products. So that's the kind of timeline you can look at. When we look at it, one of our big things is looking at precipitation. And we've got quite a gradient across Kansas. This is the normal annual precipitation based on the 1981 through 2010 data. And if you look at the far west, you're looking at generally less than 18 inches of precipitation, whereas you look at, there's this tiny sliver in southeast Kansas where they average almost 50 inches of rain in a year. So again, that's the gradient that we face. Next slide. We also have temperature to contend with, and this is the normal annual mean temperature. Not surprisingly, the coldest part of the state is up in that northwest corner, and the warmest area is in the southeast along the Oklahoma border. Next. When we're looking at the changes in that, both on the warmer temperatures, drier patterns, what we're going to be facing is the impacts of increased wind erosion potential, stress on the winter wheat, falling surface water supplies, and increased fire danger. Next. To find climate data, there are a couple of resources that you can look at. The Kansas Climate website, which is listed there, is a good place to start out. That's where you can find the precipitation and temperature by counties over long periods of time. We also have a tool that shows the precip probability. We include the freeze update. We have a lot of links to weekly and monthly updates of drought and just general climate information. Another source is the National Climate website. It's climate.gov. And the second link, climate monitoring, allows you to put the changes that we're seeing into context of the long-term period. It's a really nice way to graph or look at how those climate patterns are developing. And probably one of the ones you'll see you might visit most frequently is the Climate Prediction Center. And again, that link is there. And we'll look at some of the products that are available from the Climate Predictions Center later in the slideshow. Next slide. In fact, here we are. These are climate outlooks, and it depicts what they expect the patterns to be like in the upcoming time periods. They have a 6 to 10, 8 to 14, monthly and seasonal outlook. And on this graph, we're showing in the lower corner, the 8 to 14 day outlook. And you'll see it's predicting wetter conditions in the Ohio River Valley and in the east, and drier in the west, with a strong tilt towards dryness in the Pacific Northwest. If we look at the longer period, this is the April, May, and June outlook. Again, wet over in the northeast along the Great Lakes and dry to the west. One thing to note with these is the gradient color from lighter to darker indicates the probability of that forecast actually verifying. Where you have the lightest area, there's a slight tilt towards the drier than normal. Where you've got the darker color, it's a stronger tilt towards that dryness. It does not tell the degree to which the departure will occur. So you can have a very strong tilt to be drier than normal, but you may only be drier than normal by a couple of percentage points. Or you could have this slight chance for being drier than normal, but you end up being much, much drier than normal. The other thing to note, you want to go back one slide? Jonathan. There we go. The other thing to note with that is in this 3-month outlook, it's looking at the total over that 3-month period. So you could have a very wet start to the period and a very dry end, and the overall pattern would come out as being close to normal or drier than normal or wetter than normal. And again, it's that 3-month period. If you, next slide now. Same holds for the temperature. The darker colors are showing an increased chance for above normal temperatures. As you move further to the north, the probabilities are a little bit weaker, but it's still tilting towards a warmer pattern. Only in the extreme Pacific Northwest is there a chance for it to be colder than average. Again, I'm looking at the 8 to 14 day in the lower side and the 3-month period in the upper side. Also, again, a reminder that even though there's a very strong signal that it's going to be warmer than normal, it doesn't indicate how much warmer it might be. Next slide. So that gets us into the question of climate variability and change. The question is, what is changing and how is it manifesting? What we're seeing in Kansas so far is increase in average precipitation, warming temperatures, and mostly it's wintertime warming, and it's mostly in the low temperatures being increased warmth in that low temperature, and an increased variability. There's a slight increase in the average growing season. Some of the problems that can come with this kind of scenario is that if you look at that winter warm temperatures and increased low temperatures, that means you're going to have a better chance that your vegetation is going to break dormancy early. That increase in average growing season length doesn't really mean that you've eliminated that chance of freeze. So if you have a very mild winter and you've got your wheat up and growing and you get hit by a normal freeze date, you're more likely to have damage with it. Another factor that comes into play with this, particularly when we're looking at water resources, is that those surface water supplies may not freeze over. So you can have higher evaporation from those than you would typically see during the winter season. Next. Again, one of the difficulties in developing a pattern is noting that historically we've had quite a range in rainfall totals across the state, from very, very wet to the very, very dry. And so sorting out whether or not this is a climate change impact is a little bit more difficult. Next. But it's not just the annual precipitation that's important. The timing of that precipitation can make a big difference in its impact. On this graph, I'm showing in the dark the long-term historical rainfall pattern, and that's based on 1896 through 2010 data. The three colored lines indicate the different normals period. The orange is the 1961 to 1990. The yellow is the 1981 to 2010, and the green is the 1971 to 2000. And what you can see from that is we've had a bump in the average rainfall in the late winter, early spring, and a slight decrease in the summer precip. You notice that it's noticeable in the 1961 to 1990 and not quite so noticeable. In fact, it's actually looking wet for the 1991, and the 1971 to 2000 and the 1981 to 2010. There's 1 month that has skewed these values, and that's the summer, July of 1993. And if you take that out, this upward pattern here drops down and more in line with the 1961 to 1990. There's also a slight increase in the wintertime precipitation. Some points to remember with that is winter is our driest season, so it doesn't take much moisture for it to be above the long-term average, and it's less available to our vegetation in the wintertime. More of it is lost to evaporation. Next. And it's not only the seasonal pattern of it, but the rate at which the rainfall comes. And I picked a station here in the central part of the state, McPherson. This is a long-term station, a centennial station with data back to 1900 and about 95% complete observation. So it's a very good station to look at individual extremes. And what I was looking at here was the number of days with intense precipitation. And my threshold for an intense precip event was 2 inches in a 24-hour period. So we can look at here, and over that first normals period, we had just about 35 days, decreased in the 1911 to 1940 time period, but has been steadily increasing from that period on. And as we get into this 1971 to 2000, we're looking at about 55 days of 2 inches or more. So next slide. Not surprisingly, that's translating into increased floods and increased flood magnitude. This is from the 3rd National Climate Assessment Report. And again, we're looking at percent change per decade, and the larger the triangles, the bigger the percent change. And so we're seeing some fairly good changes in the eastern part of the state, not so much in the west, but again, they have had those flooded incidents out there as well. Next. And the immediate impact from that is something similar to what we saw in Manhattan after the Labor Day storm of 2018. A lot of property damage, but also you have a lot of contamination that is being spread across the area, and that is likely to be an increasing problem as we go into the future. And the difficulty will be that we're facing both extremes. So we can have the drought, but we can also have the floods. So the challenge is being able to prepare for both of those events. Next. Some resources for getting the information, additional resources, weather.gov, which everybody should know about, climate.gov, the Climate Prediction Center, and the last one I want to mention is Community Collaborative Rain, Hail, and Snow Network. It's a group of volunteers that are using the standard 4-inch rain gauge. Everybody in the network is supposed to use that same gauge. It's manual observations, but the cost of a Cocorahs gauge is much less than any other monitoring system, and therefore you can afford to deploy a lot more of those than you can, say, a Mesonet tower or even a home weather station. Next. And here is our contact information, and then I will turn it over to Chip.
Great. Thanks, Mary. All that contact information at the end. So my name is Chip Redmond. I'm a meteorologist at Kansas State University, and I also manage the Kansas Mesonet. So today we'll talk, kind of pair on to what Mary started, where she focused on the climate aspect. We'll talk a little bit about the weather and kind of real-time tools and data availability for you all. Next slide, please. So weather data comes in many forms. Some are usable by scientists, and some are more public-oriented. And these days with technology, it becomes kind of a little bit more of a gray line there, as some people can educate themselves and you get really knowledgeable. So there's a lot of resources out there. I'm going to focus today on just the resources that are more driven specifically to producers or decision makers in water resources, and not so much the scientific stuff. Next slide. Unfortunately, with all this data, we have a lot of data that still is not very descriptive or detailed enough for what we need for decisions in the field. Some really good examples are, evapotranspiration and inversions. Inversions are really hard to predict. I know there's some apps out there that try, and I've also know that those apps have not necessarily been reliable, just because it's such a small phenomenon of basically micro scale meteorology, small scale, like in field or in a valley meteorology. That's just really hard to forecast for, almost impossible. So that's where a lot of things need to be done in the field, such as Cocorahs, as Mary mentioned, that can help people understand those forecast needs and help the decision support at that small scale. Next slide, please. The good thing is that when we do a lot of small scale forecast or observations and whatnot, it plays back into the forecasts. So all the dots you see on that chart are observations that were taken and compared to a model run in a forecast model run. So basically, at the beginning, you see that those dots followed really closely to that line. And then as we get further out, the forecast has a lot more variability. And so the observations don't track it as well. However, if we have more observations, like let's say Kansas Mesonet data or Davis backyard weather station data, that in turn goes into the forecast model and help it verify. So these small scale, even like Cocorahs observations, go a long ways to helping you get better decision support in the future. Next slide, please. In another way that to understand the forecast data, we need to put it in a way that's usable for the producers or usable for the decision makers. You can see a chart that can give you precipitation like this one across the entire US, but what does that really mean? Does that really mean, let's say I'm in the green and I'm going to get a ½ inch? Does that mean I'm going to get a ½ inch? And so how do I measure it? How do I verify it? And how do I put it into a way that is replicatable with other people across the same area, so we don't have someone measuring in their wheelbarrow? So that information is really important too. So you have to have some sort of quality control, some sort of basically standard that can go in place to help build better tools for decision makers. Next slide, please. So observations are critical, whether they're manual or automated. I know some people take soil temperature measurements that way, and that's great. Unfortunately, there's no way to put that into like a citizen science to help give back, but that's where the automated systems come in. And that variability across small areas is really high. But we try to capture most of that by weather observations on a smaller scale, such as the Kansas Mesonet. So next slide, please. So the Kansas Mesonet is a network of weather stations. It's 72, 73, probably 74. I think it's 74 now. 74 stations. The stations highlighted there were the ones that were added last year, the permanent full-time stations. So we measure soil temperature, we measure temperature, humidity, all the basic weather parameters. In addition, we also measure inversion data, and we also measure soil moisture data, which play a huge role in both water quality and water availability. Next slide, please. So all that data is available at our website. That's open to everyone. I'm hoping everyone on this call has used that data at some point. You can just go to mesonet.ksu.edu. I'm going to talk a little bit later about just a couple of tools we have. And you see those 3 bars up in the top left of, let's say, that box there on the right side. That is the menu that'll take you to all the additional tools. Next slide, please. As Mary mentioned, Cocorahs is a big one. I won't hash on this too much, but I know there are some producers out in the Southwest, Kansas, that in order to get better irrigation in field by field basis, they have one of these out at every field. Now, granted, it's different from one, north side of the field to the south side of the field, but by building a network or a small scale data availability for you, you not only help your operation, but you help, if you were to report all that information, that would be a huge data resource that would join thousands of others across the the state, like I have shown there from last week's precipitation event. Next slide, please. There are also a lot of other applications out there. This is just Wonder Map. It's just one resource of backyard weather stations that's great if you want really close weather station to your home, or you want weather station in your backyard. But it also comes with a lot of caveats with it. We'll talk a little bit about that coming up. Next slide, please. And then, there's also aggregates of that weather data. So the Drought Monitor is a really good resource for drought indications, but is kind of a post-process, like observations, right? We take observations and they help us build a historical record of what's going on, whereas that forecast data does not go into the Drought Monitor at all. So those are observations and forecast data are two different things. So we look at all the observations, then we aggregate it into basically above normal, below normal, and then impact based as well. So are we seeing pond levels drop? Are we seeing streams not run? Or are crop fields drying up? And those impacts really help drive the Drought Monitor. So Drought Monitor takes those observations with the impacts, and it is a free resource to you. The website's down there in the bottom right, droughtmonitor.unl.edu. It changes every week. It's updated every Thursday. I'm sure most folks are pretty aware of this, but if you're not, it's there. It's another tool to put in your toolbox. So like I mentioned with the Cocorahs rain gauges, it's really nice to develop kind of what I would call a micro scale or micro net of sorts. That's, Mesonets on a statewide scale. We have a station in every other county or every county, depending on where you're at. But for your operation or some of these smaller scale things, especially irrigation, we need almost a micro net or a small scale network. So that's why a lot of people put out these weather stations, which are great, but you have to know where your data is coming from. So if you're located in the city and you have a weather station that's in the middle of, this one's in the middle of Hayes, is that really applicable for your operation that's south of town? Yeah, no, not really. So you just have to be aware of where this data comes from. But it's also super helpful if you can have these located. I know there's a lot of companies that use them for irrigation applications. And when they're close to the field and representative of the field, they're really, really good. And the more stations you have out, the more accurate, more reliable decisions you can make based upon that data. Next slide, please. But like I mentioned, you have to know your local factors. So the top two images, the left and the right side, were taken at, it was what, 3:30 in the afternoon at near Sharon Springs in Wallace County. They both had a southerly wind at 14 miles an hour to 15 miles an hour. But then 10 minutes later, this is a day where southerly winds were prominent across the area. We see the wind shift directions completely at that Wonderground station. And so the Mesonet still had winds out of the south. So this is where we start to look at exposure and reliability outside of your small scale. So if you don't have a weather station and you don't know exactly where it's at, you need to research this information, or else you might be getting data that could falsely provide inaccurate data for your operation. So just be aware of some of those idiosyncrasies and caveats of these local stations. They're a huge asset, but they come at a price sometimes if you're not willing to do the research. Next slide. There's also a lot of other caveats. I mean, like Mesonet, for instance, I'm not saying we have little idiosyncrasies as well. And that's just an unfortunate thing. But if you have a question about something or you see data that's possibly erroneous, don't hesitate to ask us or check our Twitter feed. We usually update a lot on there if the weather station's down or similar. But that goes into that research part. The left picture there is, an ASOS weather station that's maintained by the FAA. They're at airports. They're high quality, but they have limitations too. They use sonic anemometers for their wind speed, and so they get cobwebs in them and whatnot, and they get erroneous wind data. And also, that weather station is located on gravel. Let's say you had that field on the other side of that weather station. Is that weather station accurate for your field? Probably not, because it's going to have a warm bias due to that gravel surface. So You know, not everyone's going to come out and say those issues, like that person did on the right side there, where they said their precip data isn't any good, so they stopped distributing that data. So you just have to know where your weather stations are located and where you're getting that data. Next slide, please. So you have all this weather data, but you have to be the one to decide, you know, what is the determination of your next decision? Where are your decision points, and how precise does that data need to be? So if you're looking at stream flow for, you know, flooding issues, I mean, you have standardized heights of when the water gets to this level, we have a problem, et cetera. Or maybe you have so much rain falls into this basin. You know, if you're looking at a small scale thing that could be influenced by, you know, high rain rates, daily observation probably isn't going to cut it for you. You need high resolution data. So you need to be able to make those decision points yourself, and you need to know what the limitations are of these data sets. So your Davis station might work real great when it, you know, the Mesonet station might work real great in the summertime, but if you have a snow impact, you need to know that there's snow limitations there as well. So understand your data source. And if you have any questions, feel free to shoot us an email about your data source, and we'd be glad to help you out to understand it a little bit better. Next slide, please. So what are a few resources for irrigation? ET's potential evapotranspiration, it's not measured, it's calculated. Not all weather stations report it, but some Davis stations do, or backyard weather stations do. But just keep in mind, the solar radiation sensor is a big component of that. You can find that data on the Mesonet site by going to Mesonet weather in the menu, and then historical weather and daily. And that'll put you a daily summary of what the estimated ET was for grass and alfalfa. Precipitation, we could get that real time and on our front page at mesonet.ksu.edu just by clicking that precipitation tab. Next slide, please. So like I mentioned, go to the menu, hit weather, hit historical weather, and then the ET is there on the right side. And grass and alfalfa, the difference is you have different heights of crop and different types of crops. So you have different evapotranspiration measurements and a different, what would you call that? I found the words. Anyways, so and then there also, you can get a daily listing of precipitation there. It's the fourth tab over. And when you pull up data for a certain window, let's say you pull it for the month, at the bottom, it'll have the summary of all the accumulated precipitation for that month and all the accumulated evapotranspiration as well. Next slide, please. So precipitation, like I mentioned, you can find that on our main page. You can also find more broader periods if you want. So if you want to look the last 30 day or the last 120 day or even the last rain event, you can go to precipitation and then daily totals. And then you can change the map there. That third arrow in the middle is showing you can change it from departure from normal to measured. And you can change your time scale as well. So you can look at, you know, how we didn't get rain yesterday. So, you know, what's our normal rainfall for yesterday? So you can look at that real quick. Next slide, please. Now, irrigation demands are going to change with crop stages and crop growth. And I leave that to the producers to know what growth stage they're at by verifying in field. But we also have a tool for that on the Mesonet as well. You can go to the menu and then agriculture and then degree days. And next slide, please. And so that'll pull up an option in the state where you can select which stations you'd like. You select what crop you have and then your time period of when you planted to current, and it'll show you an estimated of what stage it's at. So you can put all three of those tools together and get a really good idea of what you need for irrigation. Next slide, please. So water quality is a whole nother component to water resources. It's not all irrigation. Soil moisture is a great indicator for, you know, ground saturation and water infiltration into the soil. You can find that at the menu in agriculture and soil moisture. And then in addition, you know, spraying has a herbicide pesticide component to it. And you have to be concerned about water runoff and drift as well into water resources. And so you can find that kind of data at the menu and then agriculture and inversion. Next slide, please. So this is a quick shot of the soil moisture page. It's an older graphic, so there's more stations now. But you can look at it spatially across the whole state, or you can look at one point and see where it's changed with time. So the inversion data is also available there, and you can look at the wind speeds and wind direction. And then the biggest concern with inversion is it traps a lot of those particulates at the surface and doesn't let them mix vertically, and so it can contaminate water resources around you. So just be aware of what wind direction you have and if there's an inversion in place, and know those dynamics behind it. Next slide, please. So livestock is another component of water quality, whether it's runoff from water ponds or storage ponds, or whether it's water availability for crop or for cows or other livestock with excessive heat. So we can look at the excessive heat with the Animal Comfort Index. It's found under the Agriculture tab on the Mesonet. And then there's also, we had a really bad year in 2019 where we had a lot of mud, and combined with the cold, it was just really rough with cattle. So you can use that soil moisture page as well to look at, is 100% saturated? Do we have, do we need to move cattle around? Are they sitting in one spot too much? And then there is also pan evaporation resources. Unfortunately, the Mesonet doesn't have them, and there's not really good one static link for it. But if you want that data, we'd be glad to help you with it. Next slide, please. So this is just the livestock page. Follows the same format. We don't do any predictive stuff yet. Hopefully in the future we will, using the National Weather Service data. But right now it's just current and observed for the last 7 days. That can help you so you know what your stresses your livestock could be under, whether it's a hot or an extreme heat stress, which will really increase that water demand, or a cold stress, which would have bigger implications for moisture. Next slide, please. So there is some forecast data you can use. I was mostly all observation data I just talked about. Forecast ET, or FRET, if you want to call it. It's available at 2 different resources with the Weather Service. And then there's a lot of phone apps out there, and I, as a meteorologist, have a lot of mixed opinions about phone apps. My biggest concern is that if you use the weather.com app or the Wonderground app, that they're good resources, but they utilize a forecast model. There is no human component whatsoever. If you use the weather.gov or the National Weather Service forecast data, there's a human that looks at all that data, which gives it just a higher likelihood of being accurate, and it's a local forecast office. So that person knows a lot of the demands, knows a lot of the small scale influences of the valleys and how the Flint Hills interact with wind differently than Western Kansas. Obviously the forecast model picks up on that, but there's significant limitations there. So I really would steer you away from a lot of your common phone apps and recommend using the National Weather Service. Next slide, please. This is just an example of the forecast ET data. It's if you go look at it geospatially, I'm not sure of any way to get it textually by location at this point, but it's an interactive tool. You can move it forward in time and see what the estimation of ET is by day. Next slide, please. The weather.gov page, once you get there, you end up on that top left, except for this morning when they had a data outage. Top left, it'll bring you up to the whole US, and you can click on that map where you're located. It'll bring you up to the bottom left there, and which is just a more localized view. Click on the map again, and it'll show you the forecast for that location. If you want data beyond just daily information, which is provided there with the images and the text below, you can see that arrow on the right points to the hourly weather forecasts too. So when you want to look at like rain rates or heavy rain events, that's a good location to go to see how much rain we're really expecting by hour. And they do that the top there of that graphic is the just a current observation near you. Usually it's usually a weather station at an airport or at the AWA station. Next slide, please. So that's all I've got. Here's some resources. If you want to reach out to us, you can go to the Mesonet site, the climate site, and that email will catch both Mary and I. Thank you.
Okay, thank you very much, Mary and Chip, for that detailed discussion about weather. And yes, we are going to be remiss if we are going to talk about water management and not talk about weather and climate, because they are all part of it. So I guess this portion is now open for questions, and as well as also invite the other panel to be able to be available for any questions that may come up. I am going to to check on some of the questions here. Okay, so I've got one. How can new Mesonet stations be added? What is the decision process?
Oh, so a new Mesonet station, it has to come from some sort of outside funding. All our internal funding goes towards maintaining the station network and basically maintaining the staff to maintain the station network. So a new weather station, once we locate a source of funding through either the county or maybe emergency management or something like that, then we'll work with interested producers in the area, assuming there is a demand for this information in that location. And then we'll try to find the best representative location. So not in a valley or not on the tallest hill, but somewhere that's representative so that data can be used beyond just that central location. And then we'll go through the process of installing it and making it available for people. And I will just add one other thing too. It's not as easy as just placing a weather station and just saying, hey, yay, it's done. Now we have the data. You know, that data costs a lot of time. And as also there's a financial need to sustain that network for that station, at least to be a part of the network long term. We put all our stations out with the expectation that they're 30-year stations so we can create a new climate record for that location.
Thank you very much, Chip. And definitely there is some commitment that comes with it, not just the process of putting it on. Okay, well, thank you very much. I am not seeing a lot of other questions, but I'd like to invite the panelists if they could say something about how they're using the data, weather and climate, and see and probably get some more questions from that discussion.
Yeah, Jonathan, again, this is Cody Miller in the Phillips Rooks district, and we're kind of new to this. I know we just got a station. It hasn't even been installed yet, a whole year in our district, and Chip was very, very helpful in this process here. I'll have to give credit to our local FSA gals. They really wanted the station in our area for our programs that we have, and it's made life on them a lot easier. But it's just really interesting. Here we had some great rain events recently, and just whether you're at the coffee shop or at the grocery store, wherever, the people are getting trained to go there to look at the daily totals, the precip, the 24-hour, etc. And that's been very, very neat and helpful on it. The other thing that really stands out, I know this isn't as much on the water side, but around the Valentine's Day when we had the very, very bone-chilling cold temperatures, that was neat to see how cold it got for how long and et cetera there. So those are some of the neat things, but I think there's so much more that we're going to utilize it for in our district, in our area for certain.
I'll just follow up on Cody's comment. Yeah, we had a number of requests from the Farm Service Agency to document the conditions that cattle faced during that Valentine's Day freeze. And they were very happy to have that weather station there to look at the fact that, yeah, the temperature really did get down to minus 28 degrees Fahrenheit. And even more important was they were able to also show what the wind chill was for that, because by having that, not just the temperature, but the wind data, that made it very useful for them.
You know what became kind of important during that cold spell that we didn't really anticipate was soil temperatures, and we were seeing soils freeze that haven't frozen in a long time, and so that had a big impact on water distribution and water lines that might have been shallower than they should have been, and also brought out city infrastructure too. So that data was used for things like that. That was a whole nother use of weather data we wouldn't expect outside the growing season.
This is David Hallauer. I'm in the Meadowlark Extension District. I've been an agent for 20 plus years, and I've used the Mesonet data a lot over time, and had the fortune over the last couple of years to get a couple stations located in our district. And so really have utilized that data even on an increasing basis. I've now got, across our district, the 2 stations in the district plus 2 more on either side that we can really use to kind of extrapolate some things. And, in addition to what all of these folks have talked about, one of the ways that I use it is it allows an opportunity to take a look back. We had an event last spring where we got warm and then things cooled off significantly for us. We were able to go back and look and, kind of see how far did soil temperatures drop? Were we going to have corn emergence issues? And then even later in the season, we had some grass production problems, and we're able to go back and pick out, in some cases, 3, 4, 5 different nights where that grass was at a critical growing stage and we had events. And so we were able to graphically, rather than us just saying, hey, it got cold and that's the problem, now it was easy for me to go back and pull a graph out, download that information and use those graphs to kind of share, this is why you might be seeing what you're seeing. Very valuable.
Thank you very much, David. And yes, I see that everybody has a different definition of cold. And so having the weather station to give us the numbers, that would be really very important. So I've got a couple of questions here. One would be for Mary. What is the procedure and the cost for Cocorahs gauge?
Well, fortunately, we have some operating budget to make gauges available to volunteers that sign up for it. So if you bought it online, it costs about $40. But we have some that we can make available to people who may find that $40 a challenge. So all you have to do is go to cocorahs.org, join, sign up, and we can send you a gauge. It's important to note that right now, Kansas has one of the national records for not so much new recruits as recruits that actually go out and do the observations, because it doesn't do any good to get a rain gauge and leave it in the box. You need to actually put it out and measure it. The other challenge that we're constantly facing is getting people to report that it didn't rain. Those days where there's no precipitation, having that record is of immeasurable value. One of the things is that it helps evaluate the radar rainfall estimates. And I'm sure you guys have all seen, especially out in the West, where the radar shows that there's rain falling over the area and you're sitting there underneath that green blob saying, no, it's not raining here. Again, the farther you are from the radar beam, the more of that evaporates before it actually makes it to the surface. And having that ground truth there really helps to validate and improve the analysis.
Very important points, couple of them. One is get that rain gauge outside and report even if there is no rain, because zero data is actually still an important information, particularly in the weather realm. Chip,
yeah, Jonathan, one thing that's becoming a problem across the state of Kansas and even nationwide is that a lot of our climate sites they've been recording data for 10s, 20s, 30s, 50s years, 50s, if not longer. And, you know, we're running out of people that maintain them too. So now there's even more weight onto, you know, Cocorahs and these other networks to really kind of pick up the ball and carry it for the climate reference station. So, you know, I'm not saying that Cocorahs will become a climate reference station by any means, but it provides additional data to help build some of these records that might be becoming less and less available.
Okay, thank you very much. So I think I got another question again for Mary, but okay, we'll divert that question. But the couple of questions here are still going to Mary later on. So anyway, keep on sending some of those questions, and we'll try to get them answered here once we've got Mary available. But the definitely, Chip, we see those situations wherein we could see in the radar that it's supposed to be raining, and we get out and we don't have any. Do we have to call you to get that rain coming in, or it's just a natural phenomenon that's coming, that's really happening with different weathers, with different sensors out there?
Yeah, so rain's just such a highly variable thing to measure. It's really difficult, and that's where, you know, that's why a lot of folks put a weather station out at their own field, is because it just changes so much across short areas. You know, I might just take this chance and ask Cody or David, you know, has your knowledge of the surrounding climate has definitely increased, I think. So because you have data in your backyard, but you know, how much work and effort did it take for you to engage with some of these water resource people in your county, and have you, or do you think there's room for growth there, and how difficult has that been?
Yeah, I think obviously the local NRCS and FSA, you know, they're the ones that really wanted it to begin with, so they've jumped on board with it. Some of the others, I need to do a better job of reaching out to them. I haven't quite got that feedback from them yet, Chip, but where it's here and almost going on a year, there's so many more people, not just those organizations that are utilizing the data.
No, when we had the 2 stations that went in our district, you know, there was you know, a utility and insurance agent and some producers and a ag retailer involved. And so I think that kind of shows a little bit about the breadth of interest that there is, you know, whether that be for their clientele. I know in the case in discussion with the insurance agent, you know, he was looking at, you know, more information that would help, you know, discern whether certain products would be available to producers in his area. So, you know, and that doesn't even touch the amount of information that I think, you know, local municipalities or water districts or electrical cooperatives or anything like that. I think there's just a mass of data that can be pulled, you know, whether historically or real time, that can help some of those things. So I think in our district, I think we've just scratched the surface of what we might be able to use it for.
Okay, well, thank you very much for sharing those insights again. Chip, I'm not sure if this is something that you might want to tackle, but there's a question regarding the any ideas of why the rain events are becoming more intense?
Yeah, that's a great question. So one of the main factors of it is overall warmer temperatures. We're getting more evaporation off of both bodies of water and in the ground. And as a result of the atmosphere can hold more moisture. And so if it can hold more moisture, when we get a rain event, it tends to drop more moisture. And so we see that kind of positive feedback. And I know where this question will go. It's not necessarily because of irrigation, but it's just we're getting a lot more, like, for instance, you know, we're having rising sea levels in just inches of increased water surface globally can significantly impact the amount of moisture available. Now, With that said, it doesn't necessarily mean that there's always more moisture present. We have seen much more drastic switching, and we have to keep in mind too that climate is the average of the extremes, right? So it's your extreme wet and your extreme dry average into some non-existent number in the middle. It will never be average, and we will always shoot for it, but we never will. So, you know, we are seeing still those swings from the extreme wet to extreme dry. It's just when we get wet, we get really wet, and then we tend to, when we get dry, it dries out quite a bit too. So that's the main reason we're seeing increased precipitation and heavier rain events.
Okay, well, thank you very much. Mary, I'm going back to you, and I think this is from Stacy. Can you generate mailing list for my watershed counties to do a thank you, and also remind them to get people to report again? And
Right. She's talking about the Cocorahs.
the Cocorahs, that is correct. Yeah.
And I can do that for her without any problem. I just need to have a list of which counties are in her watershed, because I'm not that closely connected with that to remember them, but I can do that. The other thing that we can mention, if any of you deal with Cocorahs observers, some of these have been observing since 2004. And their gauges may be getting a little bit old and hard to read. We can work on getting them replacement parts for it. We had a couple of them last summer where they lost their gauge due to hail. And then with the different wildfires, we had a couple of gauges that actually melted. And again, we can make replacements available to those that need it. Hopefully, we're going to just have a nice normal season and not have any hail and not be too dry and, you know, all of that perfect stuff, Camelot weather. Unfortunately, that's not likely. My apologies, but I had an emergency call that I had to take, so that was why I was off for a little bit.
Well, Chip was also there to save you. So to save the day.
He saved me for that. It was
Yep.
Kansas Department of Health and Environment that needed some stuff. So we do go across the spectrums. It's not all just ag related. We have quite a few things that are important to the urban environment and a number of different water use groups.
Okay, so we're coming into the end of the session, but we are going to be here if there is still a lot of questions that are coming out. But in the meantime, I will turn it over to Alexi to formally conclude the day. But again, the conclusion is not the statement is not going to be the end. But if you've got other questions, I think both Chip and Mary and even Cody and David are here to be able to again continue the discussion. And also we are going to share some poll here. Please fill your answers as best as you could.
Thank you, Jonathan. First, let's maybe give a round of applause to our presenters, panelists, and moderators. Thank you very much. Very informative and useful, I believe, to all of us, members and out of K-State Research and Extension. We are definitely customers of Mesonet as well as Cocorahs network. At the end, I'm sharing the poll that please fill in your answers. And while you do so, I would like to announce the next day, which is tomorrow at 8:30 a.m. And the session would be on innovative water management technologies. It will be a really interesting session with several presenters talking and discussing soil moisture sensors, soil moisture variability within the fields, with examples on a Flickner innovation farm, as well as another interesting and recently funded and started project at Rattlesnake Watershed. So please again tune in tomorrow at 8:30 a.m. and we are grateful for you to be able to be here this morning. Thank you so much and see you tomorrow.